Thank you, Professor Krishna Reddy, for inviting me to this network of really enthusiastic, passionate researchers. And it's really an honor for me to join the group of distinguished speakers worldwide at this webinar series. I particularly appreciate every one of you who took time and joined me for this discussion. We were talking about the cold weather, and I hope my brief presentation today could provide some food for thought for everybody, no matter where you are. It's meant to be a short, sweet, but I would say challenging conversation for you to bring home while you're thinking about food and daily life and sustainability issues. So my scheduled presentation topic today is about food waste. And I know likely the topic or the theme, the methods, the approach will be quite different from what you have been primarily focusing on from engineering or hard science perspective. And I hope to bring you a different and a fresh perspective when you're thinking about the food waste management from a system perspective and thinking about the pros and the cons and the challenges, trade-offs, and the benefits. Um, um, that is mutually and simultaneously happening when we address food waste issues. Before I get started, oops, okay. I want to make a clarification. When we talk about food waste, it's just one very small set of resource management practice. And for my research, I have been working on different types of materials, different communities, different regions, and I want to highlight the significant differences across materials. So this presentation or the context or discussions, strategies, and concerns likely will be most applicable to food waste management, but I hope this will also inspire you all and bring additional thoughts, ideas when you discuss other materials. Primarily, my primary work has been focused on municipal waste, which largely non-toxic, and that is really based upon the planning and the social economic context. I did work on some of the toxic hazardous materials in terms of EV batteries, which is really bulky, involve toxic content, and requires special disassembly and special equipment and expertise. So it's not easily done in a decentralized process. For this presentation, I'm going to focus on food waste only, and later on I'll discuss the unique and particularly challenging aspect of food waste management. I also did theoretical research when it comes to urban metabolism framework that is considering the cities as a metabolic process when we think about the people who eat and drink, pee and poop. And I did this study taking a UIC campus as a small city and using the urban metabolic framework to examine sustainability and the resiliency. To that level of scale, the methodology and the challenges or the interpretation of data will be very different. So through these case studies of different materials, different regions, and different scales, I do want to highlight the challenges or the trade-offs, the system co-benefits, very different. But on the positive side, I also want to emphasize it's very, very important to look into community and the material specific strategies and also look into the system impacts. So now let's get back to our main topic of discussion today, which is food. So at a global level, United Nations published a report as the infographic shown on the left in terms of the food value chain. 13% of food is lost along the supply chains, basically pre-consumer food lost, and 19% of food is wasted at the consumer level. This also highlights the difference between food loss and the food waste, although different authors and the references define food waste and the food loss differently. and there are some heterogeneities and discrepancies in definitions. Largely speaking, in my presentation today, I'm going to focus on food waste only, mostly post-consumer food waste. However, when I discuss system co-benefits and the trade-offs, I will be touching upon food loss or other supply chains or value chains along the food system. So on the right, I highlighted a few numbers in the US context. That's where my ongoing research has been mostly focusing on. Again, this is not to say food waste is not significant in other regions or countries. It's mostly because the need of the research that has to be community and the local specific. So in the US context, largely speaking, a third of food produced never eaten. At the same time, we have to acknowledge 150 million people could have been fed by wasted food each year. In terms of landfill waste, about a quarter of municipal solid waste stream is food waste. And if you think about the climate impact, the landfill food waste in the US generates as much greenhouse gases as about 15 coal plants each year. So that needed to say about the significance of food loss and food waste. And the EPA had several, the U.S. Environmental Protection Agency had several publications recently highlighting the environmental footprint of wasted food. This chart largely following um, uh, the uh, the life cycle stages of a food system and checking into the multiple literatures focusing on the environmental impact of U.S. food waste. I have included the reference at the bottom, so if you're interested, you can certainly check out the food references and the raw data there. What it meant to show is when we're thinking about food or food wasted, it's not just the amount that we throw away, discard, or dump in the landfills. Essentially, what we have wasted includes all the inputs like land, fertilizer used, pesticides, water, or energy consumed, and then throughout the supply chain, then through the primary production process, distribution, processing, retail, or consumption stages. Each of those stages generate significant impact on the environment. In other words, when we're thinking about the footprint of food discarded, the pre-proposal stage already engage and involve a lot of the energy resources and have a lot of impact on the environment already. In other words, if we thinking about addressing food waste reduction certainly is the primary goal. But at the same time, it also means when we save even one little amount of food waste, that also means we help the environment a great deal in multiplier effects. So based upon this multidisciplinary review, the US EPA follow up on that and updated the previously published food waste hierarchy, which is showing a linear relationship to this scale, so-called wasted food scale. This definition or suggestion or guideline was initially released in 2023 report, and later on EPA updated with additional clarification for each of them. So before I get into details, I want to include the clarification from the authoring agency. This one, the scale refers to food waste only, not applicable to all types of waste, which really kind of echoing what we have been discussing. The strategies, the programs, and the analysis need to be material and community specific. Also, this recommendation or guidelines based on data available for life cycle environmental impact assessment only. It does not consider economic or social factors. In other words, this is rather the guideline in the U.S. context, and for you actively, proactively practicing in other regions and countries, likely the priority or the ranking of preferences or desirability could be very different. I'll get to some very specific details, what kind of local characteristics may play a role. But This is just kind of to clarify the the guideline or the ranking of the suggestion here is not that rigid or standard or applicable in every region. But largely speaking, intuitively makes sense. The most preferred method would be to prevent wasted food, and following up on that will be donating that or upcycling, basically repurpose food for human consumption. A few years ago, in the US context, and I think the program will be benefiting from the universal application of AI now. So I want to bring out here as a case study. In case you're interested, you can certainly check it out. In Philadelphia, they have a program that creatively accept surplus food from grocery stores. What makes it really neat is they program the composition and the quantity of surplus food each day, and then cook them into prepared meals. And those prepared meals could be still sold on the market. In their program, they basically provide either free or at a discount price. So that is example of upcycle, meaning we do not simply just compost it or leave it for other purposes. It is reused for human consumption, but also provide added value to the, the original price of those produce. And also note a lot of the produce that became surplus uh, in the grocery store setting or even at home, mostly because they do not look perfect or pretty, doesn't mean they are not edible. So the program in Philadelphia really tried to help recover and rescue those imperfect foods and achieve the upcycle option. All right, so following up on that, the wasted food scale shows other preferable options would include feed animals if they cannot feed people, or leave them unharvested, basically generating a circular economy or a recirculation of nutrition in the field. And then it will be the composting option, either with air or without air. And you see the pink approach on the other end of this scale, which is to send down the drainage, landfill, or incinerate with or without energy recovery. So interestingly, I do want to bring out this evolving trend or guideline. So a few years back, speaking of a planning perspective or planning programs in the context of New York City, for example, other major cities in the U.S., there are several programs that specify new buildings, new apartment buildings need to have in-sink disposal. In-sink disposer meaning you put food scrap in it and then well, after some grinding and huge noise, it grinds food and leave food to the sewage system. So for a long time, it was considered as a good practice to reduce waste. But that's one example of the system trade-offs. On one hand, we reduce the burden on landfills and the reduce of food waste sent to the municipal waste collection system. Same time, it adds to the burden to a wastewater treatment. So I was surprised to see it didn't take long until the environmental agency realized it may not be enough just to focus on solid waste volume reduction. It also needs to consider cross-media coordination and sustainability issues. So through my personal communication with the authoring agency and their program officers, they did mention this is not meant to be number one, two, three, or four sort of guideline for food waste management. Essentially, what I really want to convey the message is just to thinking about the life cycle or the circular pattern of food systems. That's why they changed it from the linear hierarchy or pyramid shape of hierarchy you probably all well know about to this sort of kind of circular motion, reminding people, well, we would like to have this closer loop management process of food. So given that context, I want to highlight a few things, practically speaking, why it is so important, but also very challenging to manage food waste, and why it is quite different from other types of materials we have been managing or studying. First of all, there's so limited knowledge and data about food waste, and we do not know where they get generated, the composition of food, the flows and destinations, even for regions that have a lot of data, as far as I can observe. Most of the time, we may know the first destination, but we do not know the final destination. We do not know exactly which environmental media they enter, and given all those limitations, we do not know the consequences of that. So it's really hard to measure and redesign and improve the system. Also, there are so many heterogeneities across the community and the regions. Now we are basically collaborating among this global network and the infrastructure regulation, the policies, the waste composition, and management methods all differ. And it's harder to compare apples to oranges and to thinking about which practice or programs tend to be more preferable than others. The third one, which or a couple of others, bullet points here, really relate to the social economic perspectives that my research has been focusing on. So technically speaking, um, the we have the solutions. Technically speaking, there eventually will be the equipment and the technology and the logistics strategies available to rescue and recover food. However, if we're thinking about the reality, food waste typically considered as a relatively low residual value. And the low residual value could also refer to the energy content, could refer to the catch value. And there's a high contamination risks related to food safety and health issues. And also they generate frequently. Recall we just talked about other types of waste generation, for example, EV batteries. Then EV batteries, when they reach the end of life, they do not quickly get out of the logistic chain, right? So we do not need to recover or collect them like every day or for time sensitive matters that doesn't need to be happen instantly. Um, Given all those small values, they are actually generated from a large number of locations. So that definitely adds to a lot of the logistic challenges. Same time, we do not have strong economic incentives to reduce food losses and the wastage, especially for non-industrial sectors. Um, Most of the time, in the U.S. context, waste discarded and residents or consumers only need to pay a flat rate. So it does not really help them save anything if they reduce food loss or wastage. Essentially, what we see here is the strong need for multiple types and complementary infrastructure and programs in place in support of circular economy. However, the current practice definitely shows the silos of sectors and at the local level, although local characteristics play an important role, the solutions and the impacts and it depend on the local characteristics. We do not see a lot of the local context strategies and programs implemented or analyzed or designed in a way that address those local characteristics. Um, so, following up on that, I want to highlight some of the system trade-offs that I think present great potentials for research. First of all, when we put this in the context of zero waste management programs, food waste is one of them, and definitely plays a very important role considering the the water content, the weight, and also the potential contamination risks. However, given what we just discussed, the low residual value and the high demand for transportation related to both collection and the drop-off delivery process, then it's harder to meet the goals of both zero waste and economic efficiency. Also, if we want to recover food waste or rescue that, that means we are transforming or changing the practice from long-haul transportation to regional landfills to local, short, and time-sensitive trips, especially if we're considering the food recovery programs for human food consumption. That does require very sophisticated and complex logistics management. When we thinking about the food recovery process or waste to energy process, what it means it's the net that matters most. And for all those processes, there will be energy and resource requirements for storage, processing, and redistribution. If we're thinking about the residual value and also the large number of locations we need to manage for non-industrial source of generation, we will imagine the net may not always justify all the efforts we are putting into the food recovery system. And also, if you reflect on the wasted food scale recommended by the federal agency, like the U.S. Environmental Protection Agency, the national ranking does not always apply to each local and regional programs, and the local impacts could heavily depend on local characteristics, and that could basically create inconsistencies compared to the national ranking. The local impacts could also depend on the local characteristics. Here, I'm just highlighting a few. For example, what type of fleet has been used, what type of fuel the vehicle has been using, the collection method, would that be decentralized or centralized? For built environment, simply put, considering the context in the urban versus rural areas, and the collection efficiency would be different. And the land use pattern would also determine if actually it will be more beneficial for backyard composting, for example, versus transport long distance to get to the site and facing the risk of food contamination. And speaking of people, right, coming from planning background again, we are focusing on building environment, we're focusing on people. So when we think about local characteristics, participation rate also matters. It directly determines either the economies of scale or diseconomies of scale when it comes to the food recovery and the collection process. So I will go ahead and introduce you to some of the specific cases of study or data we have been producing or analyzing. Um, this is a case study we did in Chicago a few years back. We acknowledged the lack of data when it comes to food waste planning process. So we did the food waste volume estimates and trying to make it at a granular level of scale. So the maps shown here are the food waste inventory at a community level. In Chicago, we have 77 communities or neighborhoods like that. And largely speaking, we found the residential sector contributes the most to the food waste generation, and that is really kind of educational opportunity as well, because most of the general public would like to refer to the industry sectors or commercial sectors as the ones that pollute the environment. But essentially, when it comes to the general quantity, food waste generated from home locations tend to be more. The market likely has played a role because for large generators like industrial sectors, commercial sectors, they would have need to pay landfill disposal fees or tipping fees for that. And for for their strategic planning process, they would have already thought about alternative ways, either donating them or find the industrial uses to manage those food residues. But for residential sectors, because they do not need to pay for food waste generated or discarded, they likely are not responsible for economic consequences. It's most convenient for them just to discard that. So that largely explained the pie chart on the left. In terms of spatial distribution, the blue one on the left shows the community level food waste generation tonnage per year. And the orange one, the map on the right, shows the density. For those of you who know well about Chicago, you will not be surprised to see the food waste generation cluster or show highest density around the CBD, Central Business District area. That shows the darkest color, but also around the wealthy neighborhoods along the north of the city. Generally speaking, they represent affluent communities. So this estimate is basically coupling the local characteristics, like the sector distribution and the average sector-based food waste generation. So we can produce this local volume estimates. And then we um, went ahead and checked into the food waste donation potential. And this map shows the density of that. Not surprisingly, the darker colors, where it shows the highest density of food waste donation potential, again, clusters around the central city area and the wealthy neighborhood. Now, we use the data to illustrate the spatial mismatch between the food waste donation potential and also the community demand. So on the map, in the map on the right, it shows the supply demand index for food recovery. What it means is like in a burgundy or darker red color, it shows that's the areas that shows a high demand for food, meaning community in need of food or a community that have been experiencing food insecurity. And then for the blue color area that shows there is a high cluster of a food surplus. However, there are not many donation centers around them. So this is clearly shows um, the need for community and material specific strategies. When we check into the spatial disparity, there is a mismatch between surplus food clusters and food banks, as the map you have just seen. And also, we found there could be a varying potential for decentralized composting, as shown in the map on the right. So if we are considering, for example, community parks like potential sites for decentralized food waste drop-off sites, right? There's there's also visible disparities when you're thinking about the spatial distribution. What it really means to us is equity or economic efficiency of addressing the need of communities experiencing food insecurity. And clearly it shows the need for community-wide and cross-city coordination about the transportation and logistics. There also means resource inefficiencies if we look this from a system perspective. So one key question is how we could possibly achieve the dual goal of food waste reduction and food security by better connecting surplus food donors with the local food recovery facilities. So for surplus food donors, there could be a different composition of surplus food, like grocery stores or food services. And they do need the supplementary services and the facilities, meaning simply having the food is not enough, and simply having the equipment not enough. The question is what, where, and when to make that happen. And connecting to the next end of this flow, like food recovery facilities highlighted in the blue box on the right, what means is we need to figure out how to redistribute and process the food given limited capacity, mostly related to labor. Again, this is another likely local specific challenge or factor because in some regions we possibly need more resources or food rather than workers. But in the US context, we need more people and largely rely on volunteers. However, volunteers do not work on regular basis, which also generate uncertainties and make the outcome or the flow of surplus food rather unpredictable. And for food recovery facilities, it also involves diverse stakeholders. Some of them at the city-owned facilities, some related to religious facilities or community services. So the my motivation behind this is really trying to identify and envision those scalable community-based food recovery facilities and address the mismatch between the demand and supply under data constraints and the uncertainties, and integrate urban analytics with the local context to promote stakeholder engagement and inclusive planning process. Um, just very quickly going through the general process of that and also for clarification purposes, for surplus food donors, it could include the farms, industries, or distributors, could include grocery stores, supermarket, food services, or institutions, or just individuals or household. And food could be donated as those non-perishable food or could be perishable. They go to for processing facilities like food banks, storage facilities, or community or soup kitchens. And they could also go to distribution outlets, food pantries, and the mobile programs. So some of the processing facilities and distribution outlets joined together, same location, but in some cases they do need additional transportation and the logistics arrangement. And then from distribution outlets, the food get distributed either as donated. Mostly they will only work if they are non-perishable and individually packaged, or get further processed, for example, meal and products for resale additionally. The recipients or consumers could be individuals who come to pick them up, or could be a community organizations that pick them up and then redistribute them to their community members. We have seen in practice some of the programs that have been trying to increase the efficiency of this process. Um, Basically, what it means is connecting business or organizations or donors directly to recipients or consumers. And at the bottom of this chart, I included some of the apps or the programs to do that. And I tried a couple of them, and they're really neat. And surprisingly, they haven't been widely adopted in the U.S. context, possibly because of the lack of awareness of the environmental footprint or the lost values of those food. Anyway, so some of these programs address those imperfect produce when they do not look perfectly beautiful. Um, and some programs offer discount price for that. Some other programs connect business, private, for-profit businesses directly to consumers. For example, Too Good to Go has been really a favorite by our students. What it means is that towards the end of the day, when restaurants have surplus food, then the app would indicate there could be a surprise bag or package, and then consumers could pre-order that and pick it up. That typically involves a lot of perishable food like cookies, pizza, salad, or bread, meaning need to be consumed on the same day. Um, The caveat of that is most of the healthy food options are not available, and students share their observations. And if they use this often, then likely they live on sweets like cookies and pizzas every day. And also through our kind of sample testing, we noticed for this sort of app programs, they tend to have more participating restaurants in affluent, wealthy neighborhoods, in communities that seem to show higher demand for food or have relatively low income households. They do not actually have a lot of options when they see the participating restaurant in the app. So I think it's a very promising and exciting opportunity that actually connects the business or food service providers to consumers directly, that avoids the middleman and increase the resource efficiency, and reduce a lot of those logistic needs when it comes to food recovery programs. However, those programs are not that widely adopted or implemented or known by consumers yet. So this definitely shows the need for increasing the scale of those operations or awareness or participation rate. So, following up on that, we did a quantitative analysis trying to do a system-wide sustainability assessment of the food recovery programs. Again, this is driven by the motivation about the trade-offs. We are wondering if promoting food recovery programs would actually mitigate environmental footprint of food waste, or actually the net would be even leading to the negative impact. In other words, when we change or transform the long haul transportation of all types of waste to landfill sites and to local short trips, time sensitive trips, would that actually help the environment or actually increase the carbon emissions when we have a lot of more local trips? So we look into the market situation, connecting the supply and the demand, and check into the data, both shown in the literature and also as what we have developed and estimated in the simulation and the inventory making process. And then we factor in transportation strategies in terms of routing, whether it will be just from door to door or cross-sourcing, or combine the trips like multiple stops. And we also consider built environment in terms of types of the sectors and the density of the sectors. And when it comes to the modeling process or carbon emission estimates, we check into the travel distance and travel time and travel cost, and then get to the policy scenarios to evaluate two factors. One focusing on economic efficiency, the other focusing on the environmental impact. And those are standardized, basically the unit cost of recovery and the unit emission of the recovery process. So I do not need to go through all the details about the modeling process, but I want to briefly summarize our findings by going through the scenarios first. The We covered, largely speaking, four scenarios. The first scenario is the voluntary programs, meaning everybody can participate, and it could also involve individual donors. Scenario two, targeting large donors or focusing on the power and influence of anchoring donors. For example, large institutions like our university or commercial sectors or grocery stores could be large donors. Scenario three covers the trip consolidation option, which means it does have the one-on-one or door-to-door or individual collection system, but also considering combining the trips, not just collecting one set of donation at once. We combine multiple programs. Scenario four connecting the trip to consolidation method with the large donor option. So those simulation process based upon empirical data in Chicago showed clearly the urbanization economies or economies of scale and the density and diversity of stakeholders matter. It helped reduce the unit cost of urban food recovery programs. And we also identified the opportunities to transform economic efficiencies to cost savings. As shown in these charts, the different colors show different types of vehicles adopted, and the middle bar, the 25 to 30 cents per pound, generally refers to the tax relief or tax rebate that donors can get by donating surplus food. So what we want to show or analyze is to compare the unit cost of urban food recovery to the tax incentive of food donation. And as you can tell, some of the options do show higher cost than that, but some of them get lower. In other words, not all the options would justify the current market incentives for food donation, but strategically planning on that, especially given the volume, the density of the location of the donors, some of them could actually justify the case and make it more environmentally friendly. This one focus on environmental factors. Similarly, as you have seen earlier on, same scenarios and same representation of types of vehicles, and we are checking into the benefit of avoiding the food waste from landfills and check how the environmental benefit would of food recovery programs will compare to the food waste diversion. So again, there shows some potential opportunities, and not every scenario will work, but there are possibilities to make it happen. Essentially, what it means is we see the potential, we see the opportunities. We could transform urban challenges to opportunities. And when we're thinking about the common challenges in urban areas like environmental pollution, economic inefficiency, social disparity, or community nuances, and we could leverage the benefit or the attributes of urban centers in terms of the density and the diversity of the reuse sector, and then achieve healthy environment, cost savings, job opportunities, and community engagement. Essentially, we do need the food waste quantity, quality, and distribution data, and need a redesign of the system to make it happen. But essentially, this shows there are opportunities that are untapped, especially in urban areas when there shows the density of the problems, but also density of the opportunities. Now, reflecting on that, recall we just had an earlier discussion about the United Nations discussion about the issue of food waste. But I also want to say potentially when we address food waste management issues, we could also touch upon or contribute to the co-benefit almost every single goal of the United Nations SDG, Sustainable Development Goals, from economic to social issues. And that not only covers food security, but also health issues, job creation that also relate to economic development and related to climate. We just showed the environmental emission analysis, and also related to the composting part of it. Speaking of composting, I want to use some of my remaining time to highlight an emerging challenge related to PFAS. PFAS, commonly considered as a forever chemical, has been increasingly been a challenge for composting practice. While the food waste reduction program, also in connection with the composting programs in the news, we have seen a lot of disrupted operations in composting facilities. Some of the composting facilities even ceased operation because even after they go through the composting process, the end product no longer safe for landscaping or urban agriculture or for fertilizer purposes. And even in a serious situation, some of the biggest composting plants were forced to close. So one of my ongoing projects, following up on that, the same time checking into the co-benefits of food waste reduction, but also on the co-benefits of reducing the PFAS in foodware and related to food. What it means is when we reduce the PFAS in foodware, we also reduce the human exposure. Well, we help provide healthy food. We help promote healthy fertilizers for agriculture production process, helped with the waste management practices in general and throughout the system. So some of the very specific items we are looking into include the cost effectiveness of those food recovery programs, including foodware and the multi-criteria planning for resource management. Next time, if I have more time, and I'll share with you more about the different perspectives in different regions, how we check into the resource management. For example, if we're thinking about reducing the food waste volume, weight, or we are thinking about reducing carbon emissions or climate impact, or if we are prioritizing the job creation opportunities, or if we are thinking about the cost efficiency. And those criteria intuitively will lead to different decisions or procurement decisions or waste management decisions. There are some other research related to this co-benefits, for example, when it comes to rain gardens or urban agriculture processes like that. Okay, so as I mentioned earlier on, one of the highlights is this Environmental Protection Agency, US EPA, supported the project on safer and eco-friendly food service products. And we are exactly focusing on those co-benefits. There are some remaining challenges. Some of you probably have heard about it in practice. When we hosted a conference gathering regional stakeholders, we identified that compostable products actually in use and increasingly adopted. However, they're limited impact because even though when people using compostable products, they are short of access to composting bins on site, or they do not have the composting facilities or programs, and not all the items accepted for composting, either because of the complexity of the product or because of PFAS concerns. So the co-benefits are not that intuitively or achieved in straightforward way. And there are information gaps. Unlike food labels, we often see the ingredients and the calories for PFAS content in foodware. We do not see a lot of the information in terms of specific substances. Actually, when we interviewed the restaurants, most of them had no idea what materials are included in the raw materials they purchase. And they do not have access to such information when they purchase food or the foodware. So there's definitely the information gap. And restaurants or food service providers also, even including consumers, also curious if we pay more, do we actually have access to those environmentally friendly products, and if actually does do good for the environment. And if there's regrettable substitution, if we pay more, but eventually they still harm the environment. So all those remain to be challenging questions when we think about the co-benefits. There are some other information gaps for certain products. It is best for composting, or should we just go ahead landfilling them? Then acknowledging there are certain benefits as well, for example, logistics, transportation savings, or recycle them. And there are gaps also in terms of the compostable feasibility and if they are truly sustainable. So I included a quote from our conference attendee. They said a wide range of sustainable options can be confusing, and even well-intended solutions may not be the right fit in certain contexts. So that well-stated comment actually leads to a lot of remaining questions for research, I think, because when we define and analyze sustainable options, researchers may have our predetermined metrics or set of indicators. However, in the field, we observe certainly complications and heterogeneities when it comes to sustainability concerns. And those issues may not be easily formalized or generalized in a standardized model. So to conclude, I want to share with you a report I published mostly for the audience of planning practitioners. I want to highlight that material and waste management, including food waste, is not just an engineering problem. It's not just about the hard science. It does require multiple lens of planning and convergent knowledge sharing and collaboration, and covers a lot of the infrastructure planning programs, management programs, construction, finance, economy, equity, and technology, all considered. This is definitely a system challenge that requires all sector participation, including each individual of us, if we put the consumer hat back on. So the convergence process will be very critical for the success of achieving those co-benefits and helping us in minimizing the system trade-offs or unintended consequences. For that purpose, our project has been engaging a wide range of stakeholders, from not only researchers to industry partners to community organizations to certifying bodies and to policy advocacy agencies. And I truly believe for every one of you who are really passionate and enthusiastic about the research and has a strong knowledge base on this, together we could build even stronger network and together achieve a more sustainable future. All right. If you are interested in further update our research, I have included the URL go.usc.edu followed by my name. And you could also scan the barcode for further questions and discussions. You can reach me at this email.